is section 1310, and it's example 3 in my version of this. You notice that we have a cosine wave, and it's going to be, the sinusoidal axis is going to be 2, the amplitude is 3, up 3, down 3, right, from the sinusoidal axis. It's going to have a periodicity of, well, let's see, I'm not sure. The period, right, is going to equal what you multiply the argument by, so 2 pi divided by what you're multiplying the argument by, so pi fourths. So it's going to equal 2 pi times 4 over pi, right, the reciprocal. And so we can see that the periodicity is 8. All right, so I just kind of wanted to play around with that a little bit. And then also, just you can see also that it's going to have a phase displacement of 6/10. I think I just want to graph this first just to get a feel for what the answers will be, and then let's actually work it out algebraically. So let me see if I could kind of squeeze everything in right here, okay? Let me see if I can do it. So 1, 2, 3, 4, 5. I think that's as high as I have to go, so that should be good. We have a sinusoidal axis here at 2, right? And it's going to go from 2, it's going to go up 3, 1, 2, 3. So you know, it'll be bounded in like by this little line here, and then it'll go down 3, 1, 2, 3. So bounded in kind of like right here. Just kind of making my mind think about that. Okay, now 1, 2. Let's see what did I say was 8? It's going to go through one period in 8. So let's see. Let me let's label the x-axis. Well, let's make sure we understand that this is y equals 2. So then we know the y is counting up by ones. But let's just label the x-axis by ones too. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. There's 8. And then 9, 10, 11, 12, 13, 14, 15, 16. All right. And I mean, I don't know. So I'm just counting up by ones. So it's like 1, 2, 3, 4, 5, about right there, shall we say? 8, 9, like 10 right there. 11, 12, 13, 14, 15. I don't know. It's good enough. Okay, I get the idea. I get carried away with this. All right, now, let's see. It's going to have a phase displacement of 6/10. So that means it's going to start over 6/10. So about halfway, between 0 and 1, just a little bit more than halfway, and it's going to be at a high point because it's the cosine wave. So we'll put that about right. Sometimes I can't get that to not work or to not come up. All right, so it'll be a high point, and then the high point will be 8 units, 8.6, somewhere between 8 and 9, about right there. Don't do that. About right there, okay? 8 units, and then go over 8 more units, so about a little bit over between 16 and 17, about right there, right? And then 8 more units, 1, 2, 3, 4, 5, 6, 7, 8, about right there. High point again. So those are a lot of my high points, and my low points are just exactly right in the middle. What would you say? Just eyeballing it, you know. And eyeball this one here too. It's too hard to do it different. And then just, okay, so there we go. Do you see it? Do you see the wave? This is the fun part. I get so excited about this part here. Okay, so here we go. Whee! This is so much fun. I feel like I'm surfing or something, you know. There we go. All right. There it is. Beautiful. Okay, now let's see. What am I supposed to do here? I forgot. I got so excited. I grabbed that. Y equals negative 0.7. So somewhere like, and unfortunately I can't do it just a completely straight line, but you know, like right here. Do you see y equals? Oh, I came down a little too low there. I don't know. I don't like that. Let me do it in a different color. Let me do it like in a light blue. All right, so let's see. Just stay slightly above. Come on. You can do it. What are the first 3 values there? Okay, the pin kind of did it. All right, looks like the first 3, you know, when y is negative 0.7, that's the line I graphed right there. It said negative 0.7, right? And it wants, yeah, negative 0.7. The first three positive values of x. Okay, well here's the first one. So you could see that when I don't know, it's like right here. It looks like at about 3. Do you see? Looks like this is the point 3, negative 0.7. So that could be the first one. And then the second one looks like it's at, let's see, 1, 2, 3, 4, 5. Oh, I'm on reserve power now. I'm okay. Okay, wait, I lost it again. 1, 2, 3, 4, 5. A little bit between 5 and 6. Okay, so it looks like it's between, like, I don't know. Not quite. Not quite to 5. Maybe 4.9. What do you think about that? Okay, let's see. Let's go with 4.9 and negative 0.7. Do you see? I'm just looking at this point right here, right there. And I'm asking myself, where is that on the x-axis? It's a little bit before 5. And then right here again. Where is that? A little bit past 11. So it looks like it's going to be like maybe 11.1 and negative 0.7. And that looks like, is that what they asked for the first three positive? Find the third positive value of x for which y equals negative 0.7. Oh, so this is the only one I want. The third one, right there. There it is. Kinda. Now let's do it exactly and see if we can figure it out. Okay, because that's our guess. That's what we're throwing out there for a guess. And so let's see if it actually works. So let's go back and solve this now. All right, so we got y minus 2. Do you see? I'm just going to subtract 2 from both sides real quick, and I'm going to divide both sides by 1/3. Can I do all that at once and I'll get 1/3 times y minus 2 equals the cosine of pi fourths times x minus 0.6. Okay, now I'll take the cosine inverse of both sides. And remember of y minus 2 here equals the cosine inverse of the cosine of pi fourths times x minus 0.6. And we know what y is. I mean, we want y to be negative 0.7. So I'll replace the y with that. Well, I guess I'll... And then, can I do... I'm going to multiply everything by 4 over pi too. Can I do that? Why not? So I'll get 4 over pi, okay, times the cosine inverse of 1/3 times negative 0.7 minus 2. Do you see? Equals x minus 0.6. All right. So let's get some. Oh, okay. So now, well, I guess I could just go all the way with it, because here I am. Let's just go all the way. 4 pi times the cosine inverse of. Let's see. What is 1/3? So we're going to take negative 0.7 minus 2, right? And then we're going to divide that by 3. So I get negative 0.9. All right. So the cosine inverse of negative 0.9 plus 0.6 equals x. There we go. Okay, well, all right, now this is the problem. Cosine inverse of negative, let's see, so let's do this. Now I'm in radians, so let me make sure I'm in radian mode here, because this is all x, it's not thetas. So let me change my mode to radian, because what a bummer if we work it out without radians. And let's see, the cosine inverse of negative 0.9 is 2.69. So this is going to be 4 pi times, let's like all of this right here is going to be 2.69 plus 2 pi n, okay, or it's going to be negative 2.69, an arc length, right, of negative 2.69 plus 2 pi n, okay, plus 0.6 equals x. So that's kind of where I'm at right now. All right, now let's see. So I'm going to take here, you see what I'm going to do? I'm just going to distribute I'm going to distribute this 4 pi n to everything. To this, to this, to that, and to that. Alright, so I'm going to take 2.69 times 4, and I'm going to divide that by pi. And I get 3.43. Let's go with that. Okay. So I get 3.43 plus, now notice the pi's cancel out. When I distribute the 4 over pi to the 2 pi n, the pi's cancel, so I'm left with 8n. Don't do that. 8n. Oh, it's not working. Hang on. Let me try to get that to work correctly. Don't mess up on me now, please. Oh no. 8n. Oh, please finish, because I'm almost done. Don't mess up. Hang on. Just a minute. Something's messing up. Let me see if I can get this to work properly for just a minute. I really need my pen. Okay, so you're going to take... let me pause this.